specific examples with angles. For this example, given the diagram, so you have to take what's given in the diagram as fact, and then I want to find the measure of angle JKL. So I specifically want to find the measure of this angle right here, JKL. And what I do know is the measure of angle JKM given to me in the diagram is 31 degrees. We also know that the measure of angle MKL is equal to 85 degrees. So specifically to find the measure of angle JKL, we could use the angle addition postulate. The measure of angle JKL is equal to the measure of angle JKM. Instead of writing the measure of angle JKM, since we know it's 31 degrees, we'd substitute that in, plus the measure of angle MKL, which is 85 degrees. So then the measure of angle JKL, if you take the sum here, 31 degrees plus 85 degrees, 116 degrees. And usually it's the case that the angles are somewhat to scale. JKL, that angle appears to be an obtuse angle, and that's what we found when we found the measure of angle JKL. 116 degrees is an obtuse angle. Okay, and then for the second example, here's what we're given. The measure of angle RSU is 91 degrees. So it's not labeled in the diagram. It might be helpful if you label that in the diagram to kind of see what's going on here. But here's angle RSU, basically the large angle right here. That's 91 degrees. And then what's also given in the diagram is the measure of angle UST, that's 65 degrees. So we want to find the measure of angle RST, this angle right here. So we actually still use the angle addition postulate. So we could take the measure of angle UST. I could write all that out. I'm just going to write out the information that's given or the angle measures. The measure of angle UST, 65 degrees, plus the measure of angle RST, which is our unknown right now. If we add those two angles up using the angle addition postulate, that should equal the measure of angle USR, which is 91 degrees. Here's what we're trying to solve for. Even though there's a little bit more writing than just a single variable, that's our unknown. Okay, so you can think about it as just something like 65 plus x equals 91 degrees. And then to solve this for the measure of angle RST, we could just subtract 65 degrees from each side. And the measure of angle RST is equal to 91 minus 65, 26 degrees. Some of you might just look at this diagram, not set it up exactly like this, and just say the measure of angle RST is 91 minus 65. And that's really what we just did. Okay, for this third example, here's what we're given in the diagram. You have to pay close attention to detail. Angle CAB, remember this little square in the corner there means it's a right angle, so that's 90 degrees. We're given the measures of angle CAD and BAD in terms of algebraic expressions. And we want to find the measure of angle CAD, not just x plus 15. We have to find the exact measure in terms of degrees, and then the same with the measure of angle BAD. Once we do find those, you can check your answer because these two angles should add up to be the entire angle CAB, which is a right angle or 90 degrees. So it has to be the case once we find the measure of each of these angles that they add up to 90 degrees. Okay, but again, we could use the angle addition postulates and the fact that angle CAB is 90 degrees. So using the angle addition postulate, the measure of angle CAD, that's x plus 15, plus the measure of angle BAD, that's 5x plus 57, has to equal the measure of angle CAB, which is a right angle or 90 degrees. Once we set up this algebraic equation, now we can solve it. The like terms here, 6x, 15 and 57, 72 is equal to 90. Now we could use inverse operations to solve this for x. Subtract 72 from each side. 6x is equal to 90 minus 72, 18. If we divide each side by 6, x is equal to 18 divided by 6 is 3. Now we can find the measure of angle CAD by substituting in 3 for x into this expression. 3 plus 15 is 18. Now really there's two ways that you can find the measure of angle BAD. I could substitute 3 in here. 5 times 3, 15, plus 57. So 15 plus 57, 72. The other way that we could have found the measure of angle BAD, as long as this is correct, x is equal to 3, then you could just subtract 18 from 90 to get the measure of angle BAD, 72. So the measure of angle CAD, 18 degrees, and then the measure of angle BAD is 72 degrees. These add up to 90, which they should. And we'll talk a little bit more about this later on in the year, but these two angles, since they do add up to 90 degrees, are what are called complementary angles. All right, for this last example on 1.5, here's all the information that's given. So we have to take the information that's given along with the information in the diagram. QR, that ray bisects angle PQS. So that means ray QR is an angle bisector, which means it cuts angle PQS into two congruent parts. Angle PQR is congruent to angle RQS. Those two angles have the same measure. So if they have the same measure, yes, we could use angle addition postulate, but that won't really do us any good because we don't know the measure of angle SQP. But we do know that these two angles are congruent. So since those two angles are congruent, then these two measures are equal. So the equation that we could set up is 4x minus 10 is equal to negative 3x plus 130. Basically, once we have the equation, we're kind of solid, so we can solve that equation. Put the variable to one side of the equation. So I could add 3x to each side. I'm going to kind of do a couple steps in one here instead of taking two separate steps. So we can also add 10 to each side. 4x plus 3x, 7x. The negative 10 and 10 cancel out. Negative 3x and the 3x cancel out. It's equal to, on the right side we're left with 140. We divide each side by 7. X is equal to 20. But just because you solve the algebraic equation doesn't mean you're done. I got to go back to the original question and make sure I answer that. Find the measure of angle PQR. We have not done that yet. It's 4x minus 10. Now that we do know the value of x, 4 times x. So 4 times 20 is 80. And then minus 10, 70 degrees. So the measure of angle PQR is 70 degrees. They didn't ask us to find the measure of angle RQS. We could do that as well. If we wanted to, we could also find the measure of angle PQS by then taking 70 plus. The measure of angle RQS would be negative 3 times 20, so negative 60, and then plus 130 is 70 as well. Or just use the fact that each two angles are congruent. This is 70, this would be 70, and the measure of angle PQS, just for your information, you weren't asked to find it, would be 140 degrees.